Hello students, myself Chanel Popat. Let us discuss Introduction to Foundation. Before that, we already have understood the principles of geotechnical engineering as well as soil mechanics. Now, let us go into foundation. Here in this chapter, it is a brief from foundation like what are the types of foundation, what are the basis of selection of foundation, what are the purposes of foundation, etc. in this chapter. Let us move forward. The lowest part of the structure below the ground level, which is in direct contact with the ground and transmits all the loads to the ground, is known as foundation of the structure or foundation. So let us move to purposes of foundation. So its purpose is very fundamental to support the structure and help to transfer the load transfer mechanism, because whenever the foundation is laid, it will do what? It will transfer the load from superstructure to the subsoil. Distribution of non-uniform load of superstructure, and it will distribute uniformly to subsoil, means sometimes on the structure is uneven or loading is uneven on the structure, but foundation will do what? It will divide it and distribute it uniformly to the subsoil. Furthermore, it will provide a leveled as well as hard surface for concreting and masonry works. Masonry work means brickworks. Concreting, you know that, to take structure deep into ground and increase stability. So it will also help to take structure deep into the ground. For an example, if you want to make a -3-story parking like you see in the malls, if you want to construct a 3-story parking below your ground line, you can construct with the help of good foundation to prevent unequal settlement. So sometimes settlement happens after years. So if the settlement happens, foundation will make sure that it will be an equal settlement, not an unequal one. Let us move forward. Shallow versus deep foundation. So let us understand shallow foundation and deep foundation. So when depth of the foundation means its depth is less than or equal to its breadth of foundation, it is known as shallow foundation. Where when depth of the foundation is greater than the width of the foundation, it will be known as deep foundation. Furthermore, bearing capacity of soil is more. In the case of more bearing capacity of the soil and required soil bearing capacity means SBC is available at shallow depth. If at the shallow depth bearing capacity is available, I will construct shallow foundation. And if bearing capacity is low as well as SBC, which is required soil bearing capacity, is not available at shallow depth, you need to dig to more depth, then you will provide deep foundation. If the structure's weight is less, then you will provide shallow foundation. If the load of the structure is more high, then you will provide deep foundation so that the foundation can take the load. When water table is low, you will provide shallow foundation, where if the water table is high, you have to provide deep foundation so that the strength will be adequate. Top layers are uniform and stable. When the top layers are uniform and stable, you can use shallow foundation, but if the top layers of soil are non-uniform and unstable, then you have to go with deep foundation. Sometimes it happens that moisture content of the top layers of soils are high. Then in that case you have to use deep foundations. Dewatering is not required when you use shallow foundation, where in the case of deep foundation, deep watering is must as well as dewatering is costly sometimes as well as difficult. Let us move forward to types of shallow foundation. Now Let us discuss different types. First, spread footing, which is spread on some area. From a geometrical view, we can say it a spread footing. Combined footing. When your columns are nearby, you have to combine the footing underneath that. So that is a combined footing. Strap footing. When you construct a strap beam between two columns, there is a strap footing. A raft foundation. Sometimes on heavier loads, you have to choose raft foundation and grillage foundation. In steel construction or composite construction, you have to go with grillage foundation. Let us understand them one by one. Let us understand spread footing first. In that, wall footings. So here you can see one image. It is showing simple footing as well as stabbed footing. Here in the first image A, you can see a masonry wall lying upon a foundation, and this foundation, this footing is known as spread footing. Same way, a masonry wall which is stepped in the figure B. It is lying on again a foundation, that is a spread foundation. We can say that a wall footing. Same way, RCC footing may be there. Here in this image, you can see a column constructed on that. It is an RCC footing. When it will be used under or beneath the column. If there is a wall, you will use a wall footing. But if there is a column, you will be using RCC footing. In this, here you can see a reinforcement cage of the column, and it is joined at RCC footing. Below RCC footing, sometimes plain concrete bed is also laid because of ease of construction. Same way, you can join a sloped footing like this also. Moving further, inverted arch footing. So, inverted arch footings. Here you can see a stone column and it is lying above a arch footing. Arch is made up of stone. We can use concrete also here, but inverted arch footings are mainly used for reducing depth of foundation. When it is in a soft soil and you want to reduce depth of foundation, you can use this footing. But here at the end of columns, it must be a strong joint because it will have more reliance on this joint. Sometimes the failure of this joint is also observed. Moving forward, the spread footing, column footings, which are isolated ones. Here you can see three images. Here there is a paired footing. In image A, column is lying above a flat rectangle. That is a paired footing. Here you can see a stepped footing, column is like a stepped, right? So it is known as stepped footing. The below images are showing plan and these above images are elevation. In third case, column is in a sloped or chamfered, or we can say tapered shape, that is a stepped footing. You can see it in the plan also. So these are isolated footings, or these are also type of column footings. Let us move forward. Combined footing. So, combined footing are of two types, rectangular combined footing and trapezoidal combined footing. In the plan, you can see the below images. In the plan, you can see the rectangular shape, as well as in the plan here, you can see trapezoidal shape. Due to that, they are known as rectangular and trapezoidal combined footing. Basically, combined footing is a concept of what? If the two columns are very nearby distances or they are weaker individually, you can use combined footing. And in combined footing, if you are joining one column with if you are joining two columns with rectangle, it is a rectangular combined footing, and otherwise it is a trapezoidal combined footing. When one column is weaker than another one, then trapezoidal footings are used. Strap footing. Here you can see two columns are joined with a strap, or we can say strap beam. When two columns or two footings are joined with a strap beam, they are known as strap footing. Raft foundation. When the load is uniform and heavy, you should prefer raft foundation. In tall buildings, raft foundations are also used. Here you can see number of columns lying there, and whole base is covered with RCC. That is raft foundation. It is also known as mat foundation. It looks like a mat on soil surface. Grillage foundation. Here you can see different layers of the foundation. Here this is RCC layer, then or maybe a PCC. Above that there are girders or I-beams of steel. Same way in the transverse direction on the upper layer there are I-beams, and then it is a connection provided to the column. These blocks will connect to column with steel connections. So in steel buildings, or we can say industrial buildings, grillage foundations are used. These are very heavy foundations as well as costly foundations. So let us move forward to selection of type of foundation. So basically you should prefer which type of foundation and when. So while selecting a type of foundation, you need to keep things in mind like adequate depth. Now if you are choosing a single type of foundation, you must think about adequate depth. I mean, if the soil bearing capacity is lesser, you need more depth of the foundation. Same way, if the soil bearing capacity is available and more at shallow depth, you need no adequate depth. You need lesser depth. So this is how you decide its perfect depth. Second factor is bearing capacity failure. Sometimes you have to think as if bearing capacity is failed, or if I have assumed as bearing capacity as 120 kilonewton per meter square, and if it is failed, then what? So you have to keep a factor of safety in the picture. Settlement. You also need to think about settlement of foundation. If the settlement happens in worst case scenario, it should happen in an equal form. Same way, fourth point leads to quality of construction. If you are designing a single type of foundation, you need to check the quality of the foundation too, because if you have chosen a perfect foundation, a perfect strength, but if the quality of construction, quality of materials is not perfect, then it is in vain. Appropriate strength. You need to design it with an appropriate strength. Sometimes engineers, for cost saving, they do design a medium strength foundation. Like if the required strength is 100 kilonewton per meter square, they will design for 100 kilonewton per meter square only. You should design for more strength than the required one. Adverse soil changes. Sometimes adverse soil changes happens while earthquake or any hazards. But you have to keep in mind also that if the in adverse case scenario, if the soil changes, your structure, your building is stable enough to take that. So these are the points you should understand while selecting a type of foundation. And that's it in this chapter. We will continue learning in the next video with new chapter. Thank you.